So, we are starting with a new concept today, which is problems based on abstract concept. So, when we talk about problems based on abstract concept, we will be doing the following. Number one, we will be doing the problems which have alternate coefficients. Alternate coefficients mean that whatever are the coefficients of x and y in the first equation will swap for the second equation. Then we will cover the coefficients when they are given as binomial expression. Third, we will consider special types of lines which are concentric lines. Starting with the first one, let's look at this equation. This is the first equation and the second equation given to us. Please notice here, p is the coefficient of x and minus p is the coefficient of y in the second equation. Q is the coefficient of y in the first equation and q is the coefficient of x in the second equation. So they have swapped their positions. In all such questions, we generally follow this kind of a trend. We eliminate one of the variables. Now we can see here that the signs are different. So we multiply this equation with p and the second equation with q so that these terms become same like this. When we add these two equations, this will get eliminated and we will only get this plus this here and this over here. Minus pq and plus pq will cancel and we will have this. Now on the left hand side, x is common. So we take x common and we get p square plus q square in a bracket. Right hand side is also p square plus q square. So we divide the entire left hand side and the entire right hand side by the factor p square plus q square. We get x equal to 1. Now x has come as 1. We can substitute this value here. In the first equation, we get p into 1, dot means into here, multiply, and we get this. P and p will cancel. We get qy is equal to minus q. Dividing by q, we get y equal to minus 1. Hence, the solution becomes x equal to 1 and y is equal to 1. So the idea is that we always eliminate one of the terms because the coefficients have swapped. Let's look at another example. A is the coefficient of x and a is the coefficient of y. B is the coefficient of y and b is the coefficient of x. Let us check. Ignore the latter part, we'll come to that later. We are multiplying the first one with b and the second one with a. So we get this. Now in this question, we are eliminating the first term and then we subtract. When we subtract the equation 4 minus 3, we get the fifth equation. So we get a square y minus b square y is equal to a plus ac minus bc. Then y is common, so it becomes y, a square minus b square is equal to this much. So y becomes this entire thing in a bracket divided by this. This is equation number 6 and this is the value of y. Now we can substitute this value of y in place of x in the first equation. So 6 is input in the first equation. So this is the equation that was given to us. In place of y, we have made this input and open the numerator. So when we open the numerator, it becomes AB, ABC minus BC. And we've taken everything to the other side, taking an LCM, and we get this as the answer. So x is equal to this and y is equal to this in this particular question. So let's look at another example here. Now, this doesn't seem to be like, as if the coefficients have been swapped. But let us first modify equation number 1 by taking an LCM. So when we do that, bx minus ay upon ab is equal to 0, and ab multiplies with 0 and is gone to the other side and multiplies with 0. So now we can conveniently see that equation number 1 has been modified as equation number 3. So coefficient of x is a in the second equation and is the coefficient of y in the third one. And the coefficient of y is b in the second equation, and it is matching with the coefficient of x in the third equation. So again, we eliminate one of the terms. We multiply the third equation by a, we get this. And we multiply the second equation by b, we get this. So this term gets eliminated. And on subtraction, we subtract 4 minus 3 and 4 minus 3. This is the third equation here, not we are considering this one. So we subtract this with this and we get this equation. Y is common here. So when we take y as common, it becomes a square plus b squared is equal to b into b square, a square plus b square. A square plus b square is divided on both the sides, so y remains as b. Now this value of y equal to b can be put in equation number 1. When we do that, it becomes x upon a minus b upon b is equal to 0. B upon b is 1, so it becomes x upon a minus 1 equal to 0. Minus 1 goes that side, becomes plus 1, so x becomes equal to a. So the solution becomes x equal to a, y equal to b. So we are through with the problem with abstract problem with alternate coefficient. Now we are moving on to the coefficient in binomial expression. When a question appears like this, when x and y are the variables, but the coefficients are given in arbitrary format. That means the coefficients are not given as numerical values, but in form of a and b or some other p and q or alphabets, then that too in binomial format. First equation is given like this, and the second equation is given as a product. So first thing that we need to do here is that we split this but not fully. So we keep the coefficient together as a plus b and multiply with x. Write it like this. Keep the coefficient together as a plus b, multiply with y and keep it like this. Right hand side stays same. Now you can see that the coefficient of x is a minus b, coefficient of x is a plus b, but the coefficient of y in both the equations is a plus b. So when we subtract equation 1 from 2, this gets eliminated. And when this gets eliminated, we are only left with with an equation in x. So it becomes a plus b into x minus a minus b into x is equal to this minus this. So when we do that, this gets cancelled. It becomes 2ab plus 2b square. When we open this bracket, now we are going to open the coefficients and multiply them with x. Few things are going to eliminate and we will be left with this. And when we divide 2b on both the sides, we are left with x is equal to a plus b. Now since x is equal to a plus b, we can put that value in equation number 2. X is a plus b, so it becomes a plus b whole square. And when we do that, this gets cancelled. We are left with a plus b So we have covered the first and the second one. We will do the third one now, which is about concentric lines. Now, before we get on with the question, look at this diagram. We have infinite number of lines passing through a point. You have done the Euclid geometry in class 9, and even there you knew that there are infinite lines that pass through a particular point. Now we are looking at it from another perspective. Either I see that infinite lines pass through a point, or I can say one particular point is a solution for infinite lines. Because now we know when two lines intersect, that particular point is known as solution of those two lines. Since here there are so many lines, this point is a solution for all of them. Implies whether I solve this line and this line simultaneously, I'll get this as a solution. Or when I solve this and this simultaneously, I'll get this as an equation. Or maybe I solve this and this, then also I'll get this as a solution. Since I have an option, at times there are certain equations which may be complicated because of their coefficients, then we prefer that we choose the lines that are convenient for us in terms of coefficient. So let's look at first this example. The question says solve this and this. Up till here, no problem. After that, it says find the value of m for which y is equal to this. Now, what does this mean? Let us see. So, step 1, I have simply subtracted the equations. So, I did equation 1 minus equation 2. I got this. So, y is equal to 5. After getting y is equal to 5, solve for x. That means put that value of y equal to 5 in the first equation and you get the value for x. So the solution to these two equations is minus 2 comma 5. Now we need to look. So imagine now that minus 2 comma 5 is some particular point here, right? Somewhere here. And these two lines are passing through that. Now we have seen in this diagram that it is not only these two lines which will be passing through minus 2 comma 5, but there will be whole lot of other lines also that will pass. So let us say that this particular line is also passing through minus 2 comma 5. So when this line is also passing through minus 2 comma 5, implies y can be written as 5, x can be written as minus 2. When we do that, we get the value of m as minus 1. So what is this equation then? This equation becomes y is equal to minus x plus 3. Why minus x? Because m is equal to minus 1. So that means y is equal to minus x plus 3 is a line which is concentric with these two lines. All three of them have a common solution which is minus 2 comma 5. Let us see another example. How do we apply this to solve the linear equations? Look at this example. If I look at the coefficients, they are large numbers. In such questions, we prefer that instead of solving these two lines directly, we find another pair of lines which will have the same solution. And the technique to do so is that first we add these equations. Oh, sorry, we first either add or subtract either. Here I've subtracted these two equations. I get this. 530 is common. So the equation will be reducing. And then I add these two equations. I get this. Simplifying this equation, we get this. 678 is 226 into 3. Hence, this equation will be reduced as this. When we solve equation 5 and 6, we get the answer as y is equal to minus 1 and x is equal to 2. Interestingly, this is the solution not only for these two equations, x equal to 1 and y is equal to 1 and x equal to 2. So it's x equal to 2 and y is equal to 1, which is solution not only for equation 5 and 6, but also for equation 1 and 2. So x equal to 2 and y equal to 1, 2 comma 1 is a solution for this and a solution for this. So please remember this. If we have complicated coefficients, an interesting thing here is that again they have swapped themselves. This is same as this is same as this. And that is why it was giving us very convenient ones. By the way, this process can continue. Let us say I did not get these simple equations. Then I could add equation 5 and 6 to get equation number 7, subtract equation 5 and 6 to get equation number 8, solve equation 7 and 8 to get the solution. So solution to equation 7, 8 will be same as solution to 5 and 6 will be same as solution to equation 1 and 2. It goes on like that.